Okay, we're back for part two of counting principles and permutations today, our first day of probability, and we are back on page 2 of the probability packet. We were just getting 26 factorial for the arrangement of all the 26 letters in the English alphabet, and then I had to use the new steps, as you can see on the calculator here, to type in 26, and then it's math, probability, and then you're going to choose number 4, the exclamation point. I'll quit out of that. And I got a huge number, 4.0329 E26. That's times 10 to the 26th power. So 4.03 times 10 to the 26. Are any of these answers like a little bit surprising or alarming to you all? I mean, think about it. I wouldn't want to start trying to figure out all the orders of the entire alphabet, all 26 letters that I could write. But yet still, a 1 with 26 zeros after it, times a 4 for that matter, is just so much for my brain to even fathom. It's just alarming. Let's look at number 10. And oh man, here we go again. How many ways can you visit all 50 of the United States? That is, if you did blanks, there would be 50 blanks. You have 50 choices, then 49, then 48, 47. And this is a trip we're talking about. So the order really matters here, the way you're going to visit all 50 of them. Well, let's go back to the calculator. Let's see if it'll do 50 factorial. I say this with a little bit of fear. Math, PR, probability, down to number 4, enter. Oh, it did it. Okay, so this one gives us a 3, what is it, 0.04, and then times 10 to the 64th power. So yikes. I wonder, this begs the question. These numbers are getting huge. We don't even have names for these numbers, people. I wonder if we could put the TI-84 to the test. Can you try, what's a number you want to know the factorial of it? Could we try, I don't know, 70 factorial? So math, this is just kind of fun to experiment. Number 4. And then, oof, error overload. The TI-84 maxes out right below 70. It won't even do this for me. Certain people's calculators, the TI Inspire and maybe certain other types of calculators will go higher than this. I think this is a job for Google. I'm going to go to Google and I'm going to ask Google, what is 70 factorial? And Google tells me, oh my goodness, it's 1.197 times 10 to the 100th power. Okay, should I get greedy? Should I go to 100 factorial? What is 100? Oh my goodness, 9.33e 157 times 10 to the 157. Now, don't get too excited. If I tried 200 factorial, Google has maxed out. It just says undefined because it's such a huge, huge number. There's this learning point link will give me more of an idea of it, but in just a quick Google search, it won't go there. I actually sat around and did this for a while, and the highest one that I got to, I think, was 170. It gave me a quick, easy answer. Oh, you know, just 7.3 times 10 to the 306th power for a factorial. So there you go. There you have it. All right, back to the worksheet. Let's look at number 7. How many different ways? Okay, so this is a good challenge question. Let's switch to green. And it's a softball question, but it's not a softball by any means. It's a little bit tougher. And how many different ways, we're talking about an order here, can you put 9 players, 9 softball players on the field if only 2 of them can pitch? And where you put them on the field matters because that's the position that they're going to be playing. So I'm going to go back to the basics and draw blanks for this one. So 5, 6, 7, 8, 9 blanks. One for each of the 9 positions around the field. First base, second base, shortstop, all that stuff. But can we specifically plant the pitcher in the first spot? Because you have only 2 of your players that can pitch, so you only have 2 choices for the first slot. After that, all the rest of the players, including the other pitcher that you didn't pick, can play any of the other positions. So you've used one of the 9, now you have the 8 left over. 8, 7, 6. You do see a factorial in this one, but it's kind of like 2 separate parts to the question. One part is an 8 factorial for all the other players, and the other part's going to be a 2 for the amount of girls that or guys that you have to pitch. So 2 times 8 factorial, do a quick type in, you get 80,640 ways. So big numbers we're coming up with here. Okay. Permutations rule. So that was the other part to the title of this section, was permutation. And I don't know what the word makes you think of. It's an arrangement of items, but can you remind yourself here in big letters, order? matters for permutations. This is going to come into play big time tomorrow when we get into combinations where actually, spoiler alert, order's not going to matter. So we're going to have to kind of look at situations and judge whether or not we think the order would be important to answering the question. This is the number of permutations of R items selected from N available items without replacement has this notation. We call it NPR. You have N total items and you're arranging R of them. We're going to make a fraction for this. You're going to have a fraction here, and we're going to use factorials for this definition. On top of the fraction is n factorial. So you'll do the factorial of the total number of items that you have available, but it's going to be a little less than that. This is going to get divided by n minus r factorial, like this. You're going to notice real quickly when you get used to these permutations that you must have a bigger number here than you have there, right? You have 10 total items, you're choosing to arrange 3 of those 10. If I flip-flop those numbers, it wouldn't make much sense. How could you, if you only have 3 things available, how could you pick 10 of them? So you always see a bigger number here and a smaller number that you're choosing there. And let's go from the formula. 10 factorial over, on the bottom, n minus r, so 10 minus, sorry, that's sloppy, minus 3 factorial. So this will be 10 factorial over 7 factorial. And we probably won't need a calculator per se on this question. This is 10 times 9 times 8. And really, that's all I have to write. It's times 7 factorial up top. That's going to cancel with the entire 7 factorial on the bottom. This one, whether you type it in or solve it by hand, gives you there are 720 ways to arrange 3 things out of 10 total. And now let's just move me around the page and go down to numbers 12 and 13. It says you want to take another trip. Okay, so order matters here. A different order. I'm going to visit 5 of the original 13 colonies. That's kind of fun. But if I pick 5 of them, like what colonies do I know? Virginia, Virginia, North Carolina, New Jersey, Connecticut maybe was an original, Pennsylvania, Delaware. Help me, write to me and help me and name me the 13 original colonies. That's embarrassing that I couldn't just rattle them off. But what I wanted to emphasize mathematically is that if I visit them in a different order, that counts as a different trip. Therefore, we can do this in one of 2 ways. I'll show both. We can do blanks for this, 5 blanks for the 5 places you're going to go, and we can put the number of choices we have for each one. We have 13 choices for the first colony that we go to. Then you've used one, so you have 12 leftover choices. You have 11, 10, and 9. Our counting principle gives us this as the answer. Well, that's the same thing in shorthand as saying you have 13 colonies to choose from. You're going to make a permutation where order matters, and you're picking 5 of those 13 colonies. You're going to do 13p5. According to the formula, that's 13 factorial over 13 minus 5 factorial, so just 8 factorial. And I wonder if this, what we just wrote here, is starting to look more like that. Up top, you'd have 13 times 12, 11, 10, 9, and then 8 factorial, right? Going all the way down to 1. That should cancel with the 8 factorial completely on the bottom. And either way you do this way or that way, you get the same exact thing. Now, I want to make sure I show you how to do this on the calculator too. You can just type in those 5 numbers, and that's totally fine. On the calculator here, what we'll do is we want to go back to that same menu. I don't know if you noticed it there where we were finding the factorial key. Type in the 13 first. So that's step 1. Let me get a clear screen. I'll just clear everything. And I'll type in 13, the number that you're choosing from. Then I want to go to the same menu, Math and Probability, because that's what we're doing now. And did you see NPR was the second item in that same menu where the factorial was? You'll do 13, it'll say NPR, and then you'll type in a 5 because we want to pick 5 of those 13. Hit enter, you get 154,440 ways you can do this. I'll write that here, 154, and then I think it was 440. 440. That's a little bit sloppy. So 154,440 ways you can make that visit. Let's do 13 in a quick shorthand way. You're trying to choose a lineup for primetime shows on ABC. I love ABC, so I'm hoping you pick some of my favorite shows for that. It says there's 27 possible choices to choose from and you have to pick 4. As long as you've established the order is important, we can just write this in shorthand instead of blanks. We could do 27 to choose from. We're taking the permutations when we're choosing 4 to arrange. So it's 27p4. Same thing as 27 factorial over 23 factorial. Or for a quicker way, we could just go straight to the calculator. And 27 first, math, probability, and then NPR 4 for a permutation. Okay, good. 421 and then 200. So 421,000 and then 200 different ways. Oh, I did it again. 200 different ways. Let's scroll down. Let's see what's happening on the next page. In how many ways can 15 runners, I want to look at these next 2 questions together. How many ways can 15 runners finish first, second, and third if a tie is not allowed? And then we'll look at 13th, 14th, and 15th in a race. Well, let me do blanks for this one, right? For first place, second place, and third place, what are the choices that you have? You have 15 runners that could finish first. One of them's been chosen, so you have 14 for the next slot and 13 for the next slot. That's the same thing as 15p and then 3. Type that in and see if you get 2,730 ways. I would argue that 15 is the same exact question, right? If you're choosing slots for first, second, third, isn't that the same as picking the number of people that could finish 13th in a race? Any of the 15 people could finish 13th. Any of the 15 people could finish 14th in a race, and I should put a 14 there because we've used one person. After we've used the second person, you're down to 13. So same idea, 15p3. And you get the same exact answer. Okay, lastly, these are kind of fun, these letter games. I just picked a random state that has 5 letters, Idaho. I don't know if anybody's ever been to Idaho. I've heard they have really good potatoes there, but let's try this one out. How many ways can you arrange the letters in Idaho? I say you have 5 choices for the first letter, then 4, 3, 2, 1. So I'm going to say 5 factorial, and that is correct. There are 5 ways to arrange those different letters, and that turns out to be, we said that one was 120. But I don't want to stay so tame like that. 17 we have not embarked upon. And how many ways can you arrange the letters in Mississippi? M-I-S-S-I-S-S-I-P-P-I? Well, I don't know. A big question mark goes here first until we get another rule. If you count them, there's 13 total letters, but how many choices do we have for the first slot? Well, there's a bunch of repeats. It's harder to do blanks when identical items are involved. So this permutations rule with repeats gives us a solution to that. It says up top, you have n total items. You put that factorial on the numerator. We're going to say n factorial is 13 for those 13 total letters in Mississippi. On the bottom, you handle the repeats. The R subscripts are the numbers of times certain letters are repeated in here. So there's 4 S's. I'm going to put 4 factorial, divide that off to account for the 4 S's. There's also 4 I's, so another 4 factorial, and then the 2 P's, 2 factorial. The one thing I would alert you of is I would type this into the calculator. I probably wouldn't worry about factoring or canceling things by hand. When you type it into the calculator, do me a favor, put parentheses around the entire denominator. If there were more things in the numerator, I'd tell you to put parentheses up there too. But this is how it has to get typed in. And wait for it, there are 34,650 ways you can rearrange the letters in Mississippi. Okay, let's test that out with Massachusetts. Try 18 on your own. Pause the video. See if you can put the total number factorial up top and the repeats accounted for on the bottom. Then turn the video back on. Let's see if we match. All right, so here goes. Massachusetts. Order is going to matter here for these permutations. We're going to rearrange. I think it's also 13 letters if I counted correctly. And you can let me know if you see I made a mistake. On the bottom, we have 2 A's. We have 4 S's. And are there 2 T's? Is this the last? I think that's the last repeat. If you put parentheses around the bottom, this one is going to be, we'll say, oh wow, this is a lot more. This is alarming. 64, 864, 800 ways. It jumped way up into the 64 millions. And I mean, I'm telling you, I have a hard time getting my head around these huge numbers. I want to give you guys a challenge to the class. Can you write down your first and last name? So I'd be writing down Christa, no middle name, just the last name, Wesley. I want you guys to get your score, your number score for your name here. And you're going to just figure out the number of ways you could rearrange the letters of your name. If I count up mine, I happen to have 13 total letters, and I don't have very many repeats. I just have the 2 E's. So if I divide by 2 factorial, I get a score of, and I'm not trying to brag, but it's huge, 3,113,510,400. Guys, I'm up in the billions. 31, oops, am I in the billions? I am in the 3 billions, right? I'm at 3 billion, count them, 113,510,400. I want you to figure out the score for your name and send it to me on a Canvas discussion, and then we'll see who has the highest and the lowest score for the class. I think that'd also be impressive. Okay, bye.